Hey, good morning, everybody. I'm Alan Miedema. I'm the Technology Director for the North Shore School District up in Bothell, Washington, and a board member. First of all, thanks for coming to the conference again. Thanks for getting up at 8:15 in the morning for a Python scripting class. I don't know if that's good news or bad news about you guys. You're going to have to look into that, though. Before we introduce the session, just want to thank everybody for being here, for participating, for reaching out to the vendors and talking with them. I know I talked with 3 or 4 new vendors last night, and they were very impressed with both the event itself, but with you guys and the kind of questions you're asking, and the fact that you come and engage the vendors in some questions. They all tell me they get a lot of value out of the conference. So I'm very appreciative of the fact that we actually talk to the people who are sponsoring the event. That's nice. Today's session is Intro to Python Scripting. I think if you folks don't know Ski Kakarowski, you will soon, because he's doing 3 sessions here for us at the conference. Ski's a system admin for North Shore, has been for a long time. We're blessed to have him. I've got a bunch of North Shore team sitting in the back, per usual, here, joining us also. So I think it's going to be a good session. I hope you like it. Ski and I were just talking about the idea that we could have this be more of a tutorial and less of just an intro where you sit and watch, but more hands-on if we get some more time for this next year. So if you don't mind, at some point during the session, in your comments within the app, just if you're interested in us expanding this out into like a back-to-back session where it's tutorial, hands-on, sitting at table, actually producing work, mention that in the comments, so then when the board is doing our review, we'll know that that's something people are interested in. If you're not interested in it, you don't have to say you are, but you know, if there's interest, we'll chunk out some time and do something like that next year. Okay, Ski, there you go.
All right. First thing, if you have a laptop, you want the files, I've got another USB key, and there's another one floating around back there. Here, let me give this to you. There. Yeah. So this is basically an introduction to Python. I can't do a whole lot in an hour and 40 minutes or so, but we'll see how far we can get through. I really appreciate everybody showing up. One last thing, I will be showing Python code up here. If you're in the back, you might have a hard time seeing it. So you may want to move forward. This is going to give you a little bit of a flavor of Python. It's great for people who have no experience, have a little bit of experience in perhaps another language. If you know a lot about Python, you're going to wonder why I'm not talking about all kind of different aspects. I'm just going to give you enough so you can get started in it. We're not going to cover the entire language. This is also aimed at doing work on servers. I'm a system admin. I'm not going to teach you how to write Python games, GUIs, things like that. It's not necessarily what you would use in a classroom for teaching. Kids are more interested in fancy graphics and things. I'm not going to cover any of that. We're also not going to cover things like Python classes, metaprogramming, tuple sets, and all kinds of other things you can do within Python. I'm just trying to whet your appetite, also give you some scripts and some design patterns that you can actually take back with you and use in your job today. That's the goal. So first, why Python? It's probably the most common interpreted language right now. Everything uses it. There was an article this morning that says Netflix uses Python almost exclusively throughout their entire infrastructure. That is the same for Dropbox, YouTube, Spotify, Instagram. Civilization 4 game uses Python. Pretty much anything out there is based on Python these days. It's a real simple language. Really easy to learn. One of the things you'll notice is there are 2 kinds of Python. There's Python 3, which came out 4 or 5 years ago. That's the one you want to learn. You will see a lot of Python 2 code out there. Try not to use it. If you have to, you got to use it. They're pretty close, but there's enough differences that it will drive you up the wall if you're trying to write Python 2 code and your language is just slightly different. It's like 2 different dialects. It's like trying to speak to somebody from the deep south or something. You can't understand them, right? installation. If you're on a Windows or a Mac, you go to python.org, you download it, you click it, you install it. You got it, right? If you're on Linux, you install via your package manager. Bingo, it's on your computer. Editors. Once you have the language installed, you have to have some way to write code for it. I prefer VI, which has got a really, really steep learning curve, but is incredibly powerful, or Vim. It runs on Windows, Mac, and Linux, which is another reason why I like it, because no matter what platform I'm on, I have it there. Nano is one you can also get that runs on Windows, Mac, and Linux. It's a lot easier. It's more like Notepad. So if you don't want to go through that learning curve, you can use that. If you want to use a GUI, the problem with using GUIs is that GUIs don't reside on servers. Servers should not have a GUI interface. You don't want to install the entire PyCharm package on your server. So if you're writing Python code that's going to run on a server and then you're trying to debug it when it works on your local machine but not on the server, you won't have access to all those nice GUI tools. So I recommend that you learn to use an editor that's a CLI type editor that you can run from a PowerShell window or you can run from inside of a bash skill. If you have to use a GUI, see if we can do this. Whoops, I'm on this side, right? Yeah, there I am. I recommend the Code GUI by Microsoft. It's the simplest one. The other GUIs like PyCharm and some of the other ones do all kinds of project management and stuff that you just don't need. Unless you're writing a wonderful new Python app that's going to become the new Netflix or YouTube. For what we're doing, simple, scripts that are a couple hundred lines long at the max, or typically 10 to 20 lines long. You don't need all that stuff. Okay, let's get rid of that. Here. All right. Editors. So syntax. Syntax is how you talk the language. So if I'm speaking Japanese, I got a syntax. If I'm speaking French, I have a different syntax. Programming language are the same thing. Python has a standard for syntax. It's called PEP8. You can look it up, and they will tell you in great and gory detail all the different types of syntaxes and exactly how you should write things. This is a really little bit about it. Variables should always be lowercase. You use underscores to separate words. Use entire words. Don't use things like A1, B2, 3, C3, things like that. Use variables that mean something. So when you come back 2 years later, you can understand what the heck you wrote. Stuff like staff_UID. I tend to use plural words for groups of things. So grades tells me that's a whole selection of grades. Grade says it's one specific grade. Okay? Anything with double brackets is either a list or it's an index into something. So it's a collection. So colors will be a list of colors, red, green, blue. Colors of 2 means it's the second, it's actually the third item in that list because everything in Python is 0 based. 0, 1, 2. You never start at 1, you start at 0. And I'm going to give you examples of this. The other key data structure in Python is what they call a dictionary. That allows you to do lookups, key value pairs. And we'll give you some examples of that. So I might have a dictionary, and I can go grades of Joy will give me Joy's grades. Program syntax. Python is tab delimited or space delimited. If you use other languages and they put like a semicolon at the end of every line or something like that, nothing. There's nothing like that in Python. The spacing is absolutely critical. So if I go if num is greater than num2, I have to space over exactly 4 spaces or 2 spaces. You pick a standard. The standard in Python is 4 spaces. I recommend you use that because if you don't and you share your code with somebody else, they're going to get really confused. So everybody in the Python world, indentation 4 spaces at a time. You do not want to mix tabs and spaces. Python will consider a tab to be different than a space, and you'll get an error when you try to run your program saying, I don't know what you're doing here. You got tabs sometimes, and you have spaces sometimes. You have to be consistent. I have my editor to replace all my tabs with 4 spaces. This is how I configured it. So I'm using spaces throughout. Functions are a way to take a chunk of code that you're going to run multiple times over and over again, like create UID. For every single person, I have to create a UID. I don't want to have to repeat that code multiple times in my program. So I write a function that allows me to encapsulate it, and then I can call the function. It runs the code, gives me back a UID. Anything with a pound sign as a comment, the Python interpreter totally ignores it. So I put a comment, it ignores it. So I can comment out my code, so I can kind of remember what I did, which is very important. Basic Python script template. At the beginning, that should have been Python 3. That line there, that is called a shebang line. That tells your Macintosh and your Linux machine that this is now all Python code. So the machine knows how to read that. On a Windows machine, you have to name your file .py. That's how the operating system knows how to interpret that file. This is how you do it. And you can leave that code in there for like a Windows machine. So all your files should start with what they call a shebang line, pound, bang, the path to the Python interpreter. I always put a little comment in there saying, I wrote it, when did I write it, and what the heck am I supposed to be trying to do with it? Because again, you will come back to code 4 or 5 years later and you're saying, what am I doing in here? The next step, you import libraries, or what they call modules. You don't ever want to write a whole bunch of code yourself. You're writing glue code between something that somebody else wrote. You can write something that will output a CSV file, right? Print double quote, print my variable, print double quote, print comma, print double quote. That's a lot of work. Or I can import the CSV module and say, spit out a CSV file. Somebody else has already done all that work for me, right? Then I have some what I would call constant variables, or things that I might want the user to change. I got my main program. I got all my functions. This little bit at the bottom we'll talk about in a little bit. It basically allows me to run this as a module, so I can import it into my code, or as a main program. And I got an example of that. But you can use this script template. It's on that file I sent out. So when you're writing Python code, just take the template and then start modifying it. Talked about that, yeah. So the script writing process. First, list all your inputs. What type of things do you have? Are you reading from a CSV file? Are you getting data from a user? You know, like, are you going to prompt the user for data? Do you get data on the command line? Am I going to type create UID space and then a file, a CSV file with a bunch of names in it? So figure out what your inputs are. Then you have to figure out what type of output you want. Are you writing to a database? Are you writing a CSV file? Are you going to display it on the screen for the user? Then figure out what functions that you're going to do to take that input and convert it into that output. That's really all we're doing here, is we're taking inputs, converting them to outputs. You write your program incrementally. First, you would just write a little bit that would read your input and maybe print it right back out. Good, I can read my input. Then you might say, okay, now I want to print it out as a CSV, so I'm going to read it in, print it all back out as a CSV. Great, I got that part working. Then I'm going to start modifying it. Maybe I'll read it in and I'll create a UID and I'll print the UIDs out in addition to the first name and last name. If you are doing user input, user configure all input, check the heck out of it. You may say input a number. Somebody is going to input ONE. You may say input a username. They will input something with a whole bunch of question marks and who knows whatever else. They will try to break your program. So anytime you're doing user input, you really, really have to check it. If you get an input from a machine, like a CSV file, it's not as critical, but you still do need to check it because you'll get garbage and then your program will break. Or else it'll do something that you don't want it to do. So the Python has this thing called a Python shell. You can just type in Python if you're on Windows, or Python 3 if you're on a Mac or Linux box, and it actually gets you to a Python interpreter where you can try things out. So my normal development process is to have 3 command windows open. One with my editor, I'm editing my program. One with the Python shell, so I can try out bits of code. And one where I can actually run my program. And I'll edit my program, I'll try to run it. It fails or it kind of runs. And then I'll say, okay, I don't quite know what's going on here, so I'll put some variables in the Python shell, and I'll test things out. So that's essentially what we're going to be doing over the next 20 minutes, is we're going to be using the Python shell, and I'm going to show you some of the things you can do in Python. So first thing, simple variables. These are basically a variable, if you don't know about it, think of it like a bucket. And you can put something in that bucket. It's just a box or a bucket to hold something. I can put a string like hello in there. I can put a number like 1. I can put a large number in there. I can put a float like 1.0 or 0.33. I can put a list of items in it. But it's just a symbol or a bucket or box that holds some data. That's all it is. So the basic types are strings and numbers. The variable type is actually determined by the assignment. If you've ever done any C programming, Fortran or anything like that, Pascal, you had to say, this bucket is only going to hold integers. This bucket is only going to hold strings. In Python, who cares? Your buckets can hold whatever you want. Makes it a lot easier. They have number subtypes. You got integer and float, pretty much. A float number has a decimal, an integer doesn't. That's it. Some variables are mutable in that they can be changed. So like a list can be changed. I can add and subtract to it. A string, though, I can't. I have to actually modify it and then stick it into a new bucket, a new variable. Booleans, true and false. So a program is basically take a bunch of data, you act upon it, and you spit it back out. The way you act upon it, you say, hey, if this is a student, create this type of student ID. If it's a staff, create some other type of staff ID. And then finally, the word none is a keyword. There's not that many keywords in Python. It's used to denote an empty variable, nothing, nil, null. So let's get out of here. And we're going to go start up. Python 3. So there I am. If I want to exit, it's quit. The Python 3, that's my shell. So I can type in a number equals 3. 2, we'll do 2. And I can see what that is. It's 2. Cool. Six. You can do pretty much any math thing you can do in here, right? And you can do really big numbers too. Might take a little bit. You can play with it. Let me go back over here for just a second. All right. Where am I here? And I can get floats. They also have a whole bunch of math functions. We're just going to talk about a few of them, but there are lots and lots of math functions. Pretty much, think about what you want to do in Python, and then go to Google and type in Python 3, whatever you want to do, look for the hit that says Stack Overflow. You'll get back a bazillion hits. Stack Overflow is a whole bunch of programmers and developers, and they're all ranked by how accurate they are. So when you go to Google, type in what you want to do, Python 3, then look for the hit that says Stack Overflow, and that will probably be the most accurate one for what you want to do. So for example, if I wanted to do a round, I can do this, right? Round, comma 2, and I can round it. One of the nice things about Python is sometimes you'll be running the program and you'll get something back that you don't understand what it's doing. So I can go type. That tells me what it is. This is an integer. Any idea what that may be? It's too early in the morning, huh? All right. That's a float, right? Because it had a decimal point. The other key thing you need to know is there's a thing called dir. This will tell you all the things that you can do with that type of object. So this says I can convert a float to an integer. I can see if it's an integer, if it's a real. I can convert it to a string. I can take a hexadecimal version of it. All kinds of things I can do with this. So I can go back and I say, okay, let's try that. String of the number. Okay, so now it's a string. Covered that. Oh. Remember, this is 0.067. If I try to take an integer, it just drops off all the decimal point. So I came out with a 0.
Is that just showing you a string because you've done that, or does that actually change the type of
Well, B number is that. And if you just take the integer portion of it, it's 0.
No, I'm saying, does that change the variable?
No. Yeah. If I do this, I haven't changed it at all. Very few things in Python are what they call destructive, where you actually change the variable. Yeah. It's more of a, you take something, you make a modification to it, and you put it into something else. Okay, what else do we got? B string. All right, let's do this. So if I've got this, yep. So there's my string. Can I pull this thing over just a little bit? There we go. Okay, and I can do things like whoops, that's not what did I do here? Capitalize
ASTR.
Ah, there you go. Capitalize the first thing. Or I can do okay. Python also gives you really good errors. So ATR is not defined, right? Okay, I type. It's going to give you really good feedback on when things go wrong. If you don't understand the feedback, copy it, type it into Google, look for the Stack Overflow. That's going to tell you what's going on. The other thing you can do with strings is you see that I did make a mistake there. So now it's spelled correctly, but STR. You notice I did not actually change the string. Strings are considered immutable. Once you create one, you can't change it. You just modify it, stick it into a new string.
What if instead of equals the same assignment?
That's right. Yes, exactly right. So I could do this, and this is real common. I can type. Right? So that's what a lot of people will end up doing. The other real common thing you'll see is this dot what that does is when you get input, when you're reading a file and you read a line in the file, you not only read the line, but you also read the carriage return line feed at the end of the line. This gets rid of that carriage return line feed. And we'll talk about this when I get to design patterns. It basically strips off all the spaces, carriage return line feeds and stuff at the end of a line or at the end of a string. So you'll end up using that tool a lot. And then the last things we need to talk about a little bit is the Booleans. You've got things like true. So true, false, and none. So this is how you do your logic. You'll get returns back from things saying if it's true or false. So if I have number greater than 3, false, right? If it's, that's how you map your way through your program. Any questions on the simple variables? Okay, there's a lot more functions you can do with them. Again, we're just giving you a few to start off with. But strings and numbers are essentially your simple variables. Now we're going to go into a couple of more complex variables. Let's go down here till I get to the right code. If we did that. Simple, complex variables. Here we go. Okay. These are lists and dictionaries, and Python has a whole bunch of them that we are not going to talk about. So a list is basically a collection of stuff. It can be numbers, it can be other lists. You can embed lists in it. You can put other things in it. The key thing about a list is you can only index it by a number. So indexes are always 0 up to some large number, however big your list is, right? But you can mix and match things inside of it. So in this list, 1 would be 0, that would be 1, index 4, this is index 2, so a list of 2 returns 9. All right, a dictionary allows me to index via a keyword. So I can index via ski and joy and Joe, so height of Joy would return 67 inches, right? This is very, very, very useful. And you can nest them. So if I want to keep height weight, I can put height weight inside of a list, nest that inside my dictionary. So height weight joy of 0 will return the weight of joy. Height weight joy of 1 would return the height of joy. And you can nest these things multiple levels deep. This is what they call a data structure. And literally a computer science student will spend 1 to 2 years just learning data structures. The key thing about a data structure is, let's suppose you have a problem, you're trying to create like UIDs or something. If you pick the right data structure, your code will be really short and it will just work. If you pick the wrong data structure, you're going to be fighting it the entire time. That's why computer scientists spend so much time learning how to do correct data structures. For a lot of what we do, you're just going to use a simple list or a simple array. Or a simple dictionary. That should suffice for almost everything that we do, and I'll show you in a little bit about that. Okay, let's go back and look at some examples. There we go. Complex variables. So there's my height. That's a dictionary, right? Where am I here? There we go. Height of joy. Some of the other things you can do with dictionaries, I might want to see what all my keys are. GHT.keys. So when I put the parens at the end of this, that means that's a function versus just a total value. So that gives me a list of all my keys. If I want to see all the values in it, I can get all my values out of it.
Can you sort?
Yes, you can sort. Let's go back to this one first, though. So there's a list. Lists are one of the few things, lists and dictionaries are mutable. You can add and change them. They're not like strings or numbers, right? So I can sit there and do this one, dot append. So now I have a bigger list. And we can also do some, where am I here? I can reverse my list. I can sort my list. Lists are pretty cool. You can do a lot of cool, really cool things with them. I can pull out one item on my list. And remember I said that you can do things like this. Whoops. So I can mix up different types of variables inside of a list, right? I can remove things from it.
Can you remove the position in the list? So can you do a list remove?
Yeah. Oh, you mean remove the second item from the list?
Or the third item?
The third items? I should be able to do that.
A list 2 inside the function.
Yeah. You wouldn't be using the remove one, you'd be using something else. You'd probably do it like, I'm not sure if this will work or not. I don't think this will work. I think it's going to put that word in there. Yeah.
Well,
But there is a way of doing it.
could
Yeah.
you try a list 2 dot remove end function?
Like that?
Yeah. Oh.
Nope. See, a list of 2 is actually going to return the none, and then the remove is going to apply to the none, right? So the other thing you can do is this sort of trick, blist equals So I can nest them too. So lots of things you can do with them. Finally, I'm just going to use A's and B's for this. You've got logic, right? This is one that gets people mucked up a lot. Equal is assignments. Equal is the comparison operator, right? So a lot of times you'll be doing a comparison and you'll only put one equal in there. Like you'll have if, and that will muck things up.
Is that triple equal as well?
What?
Is it at the triple equal?
I don't see a triple, it's just a double.
Okay.
Yeah. Then of course you've got things like this. So that says one of those two things have to be true. I know that A equals B is false, but A equals 3 is true, so the whole thing comes back as true. So if I want one of a series of items to be true, use ORs. If I want all of them to be true, you would use ANDs. Whoops. And if I can type. And then
Or operator or and operator also?
what?
Can you use the or operator or and operator also, or do you have to use, like, actually say or?
I always use them like this. You might be able to use the other ones. Python is a little bit different in that it does have some rigidity to it. Like you can only use certain things, but they also have a lot of flexibility. I've never looked into that. I mean, what the heck? That's what we're here for, right? Ah, come on.
I just did 1 = 1, 2 = 2. So the answer is false.
Yeah. The guy that wrote Python likes you to use words that spell things out as much as possible. So it is a little bit more verbose than other languages you might be dealing with. And then you've got the not operator. So Python basically says either none, I think, that should be true. Yeah. None or false is false. Everything else is true. So that's my logic, my complex variables. And there's the next one here. We've done that. All right. Slideshow. Start from the current slide. So now I've got variables where I'm putting stuff into, but now I want different paths through my program. I want certain things to happen at certain times. That's what branching is for. Your branching is basically an if, else if, or else. So essentially I've got account type student. If the account type is student, I'm going to create a student ID. If it's account type of staff, I'm going to create a staff ID. And if it's anything else, I'm going to say, I don't know what I'm doing. When you have a branch statement, always put an else in there to handle the cases that you don't know what's going on. Because you're assuming some data comes in. You make an assumption that they're always going to be student or staff. Maybe you got some bad data or something. That's what the else statement is for, to handle the garbage that comes through the system. So if I see something like if account type equals student, else account type equals staff, the first thing I'm going to say, well, what happens if you have something that's not a student or staff? You have a logic bug in your program. You haven't decided what to do with non-student, non-staff users. So you should always have what they call a fall through else statement that says this is where everything else goes. Where am I here? Okay. There we go. So a trick about the interpreter is when you type things in, if A equals B, I spaced over 4 spaces, I typed in this line, I hit return, I went back, it's 4 spaces. It's waiting to see if I am going to put anything else underneath here. I'm going to hit just the return key, and it's going to complete that statement. So it says A is less than B. So it actually said, went down here and it said it matched that one. I should never get there, right? A is going to be less than, greater than, or equal to. That's your basic branching statement. There's no other branching statement you can get to in Python. That's what you do. The next statement that you're going to be playing with are called loops. So loops are a way to iterate through an array, iterate through a dictionary, iterate through a file, read all the lines in a CSV file, iterate through a table in a database or a view in a database. They're all used by loops. So Python is really easy. It just says for number in the list, or for number in the file, or for line in the file. Do something to it. Or I can open up a file. For every line in that file, I'm going to try to count up how many lines I have in that file. All right, let me see if we can't do this. So there's all my items. You notice that I had that list was the third one down, right? The other thing you can do in a loop, let me see here, I need to change something here. Okay, there we go. So on this one, if the item is less than 5, I'm going to continue without doing anything. If the item is greater than the 16, I'm going to exit the loop. Else, oops. So when you're going through a list or iterating through a whole long bunch of lines in a file, you can decide which ones you want to keep, which ones you don't want to keep. You can use this like a filter. So again, if it's greater than 16, I just exited the entire loop and said I'm not going to process anything more. If it was less than 5, I'm going to continue the loop, but I'm not going to do anything to it. I'm going to skip over it. So those are the two commands you have within loops that you can play with. Yeah?
How do you break out of a loop?
The break command.
Well, in code, that let's just say you're in Python and you end up in a loop.
I'll hit ControlC or go to Task Manager.
Okay.
So yeah, if I was to do something like this, right? While true, continue, whoops, 1, 2, 3, 4, 5, 4. Now my computer is just looping forever, right? That one allowed me to hit Control-C and kick out of it. So one of the things with loops, you have to have a way to end it, or else it will just sit there and loop forever. So you've written your wonderful little program, you start it off, and you wonder what's going on, right? So here's another one.
Ski.
Yeah.
When's a practical time to use a loop?
So for you, you're in your day-to-day job.
Right.
You're coding up the storm. Somebody gives you a task. If you were to walk us, 30 seconds, a minute through a practical time versus, this abstract of just trying to.
Oh, you mean to try to do something?
Yeah, like.
Okay. So there's a great XKCD comic for this.
Okay.
If I can find it, I'll show it. Basically, if the task is something where I'm going to spend 5 minutes a day on it, every single day, then it's probably worth it for me to spend an hour or two to code something up, right? So if the task is something that you're doing every week for an hour, then it might be worth time to try to code it. What we do first is we first have the manual task, right? And I write it all down. I give it to somebody else so they can do it. Once they can understand what I wrote, then I have a pretty good set of manual steps to do it. Then I can sit there and start to do the coding, because then I really understand what's being done and all the little gotchas, right? I'll write up some stuff and I'll make some assumptions and they'll make different assumptions and, oh, okay, I got to make sure I cover that assumption in my code, right? Then once I get that down, I can code it. The other thing we'll code is things that need to happen at odd hours. You have an upload that has to happen at midnight. Well, I'm not going to stay up till midnight to do the upload, so I'm going to code that. The final things that we will code are things that are really complex that might take a lot of time. So in our current environment, doing a name change used to involve, I don't know, 30, 40 steps, something like that, a whole bunch of manual steps. And by coding it, we were able to narrow it down just a few manual steps and able to then offload it to somebody else who is less skilled to do the work.
And so the loop plays into iterating over your staff for the name changes. Is that where that loop would play in? Or?
You could do it for that. I'm going to give you a lot of different examples of where we use them.
Cool.
Right? So what I'm doing here, remember we had this thing called height weight, a dictionary that gave me height and weight of people? So I'm going to print for every key in height weight. So the keys were like Joy and Joe and people like that. I'm going to print out they weigh so much, the key, that's their weight, pounds, and how height, and how tall they are, right? If this works. Ah, I thought I had that defined. Sure, we had that defined, didn't we? Come on. Ah, we never did. Okay. Well, let's go get it defined. There we go. So output, this is another thing. When you are producing output, this looks really pretty, we can read it, and it's pretty well worthless for anybody who wants to manipulate it at all. They would have to parse all that. So there's two kinds of output. There's human readable output, that's this stuff, or even better, use a CSV. The key thing to do in a CSV is then the person that gets it can manipulate it however they want to. Example, I used to work for a private company. Every year my vice president would have to go back to the CEO and report on the dollars and cents and how well the business was going. Every year he would come back in a foul mood because the CEO would ask him a bunch of questions that we had not generated reports to answer. We were actually generating reports for things that he thought the CFO was going to ask about, never the ones that were actually asked. Finally, we got smart. We exported the entire stuff into a big CSV. He learned how to use pivot tables. He went back to the CFO, CEO, went ahead. Every question that was asked, he was able to use a pivot table to manipulate the data. Here's your answer. He came back. I got a free dinner at Canlis, which is the most expensive restaurant in Seattle. So I'm telling you, use CSVs to give it to your management staff. Use CSVs. Then they can manipulate it however they want to. Don't do flat out reports like this. You know, it just makes it a lot easier for everybody. If you are generating an output that has to go to another program, you're probably going to want to use a CSV, but possibly you'll want to use JSON because that's what computers speak. JSON is a much better format for communicating between two programs, between two scripts.
And Steve, I was going to,
Yeah.
I like CSVs too. There's a JavaScript library called Pop-Parse.
Uh-huh.
And I was just going to mention to you that it's the best one I found to like work with massive data sets in the browser. So,
Cool.
little fact for you. There you go.
Okay. So we've covered the basics here. Now we're going to talk a little bit about functions. Where am I here? I lost my mouse. Keep going to the left. It should show up. There it is. All right. Functions are used to avoid replicating code and also to make smaller chunks to help you debug them if you get a longer script. So I've got a function that creates a StaffUID here. I'm taking in first name, last name, first initial, my last name. I'm going to make sure it's all lowercase. I'm going to do a count. I'm going to say if it exists. I'm going to add a number to the end. And I'm going to keep doing that until I get something that doesn't exist. That's my new StaffUID. Where am I here? There we go. Functions are really simple. I highly encourage you to use them. They make your debugging a lot easier, and there's one other advantage we'll talk about in a little bit. How far now? Okay, up till 10. Great. The other thing about functions is what we call scoping. And what we're going to do for this is we're going to go. So there's a thing in Python called lexical scoping. So I basically have down here, a is set equal to 10. That's my variable a. Inside of my function, I then set it to 20. Inside of this function, I set it to 30. So this one, when I print it out, we'll see a is equal to 30. This guy, when it prints it out, a will be equal to 20. This guy, when it prints it out, a will be equal to 10. So one variable can have multiple values depending on the scope. And it's dependent upon how you write your code. It's called lexical scoping. If, for example, and let's just run this real quick. So I got 30, 20, my outer A is 10, my global one was 10. I've commented out that code. Any idea what this is going to print out now?
Maybe something about it being undefined because it wasn't passed to that function.
Not quite, but really close. What's going to happen, though, is it's going to say, oh, I don't see an A here, so I'm going to go up one level. And it's going to see, oh, A is equal to 20. So I should get inner A should print out 20 if I did this right. Yes. So basically, it looks in the most inner function. Is a variable there? Nope. Let's go to the outer function. Is a variable there? Nope. Let's go out to the main function. If I still don't find it, then I'll say, whoops, I have no idea what you're doing, and we'll get an error. So because this function is defined inside of that one, it doesn't go out to the global.
Oh, so if you comment out a equals 20.
Yeah, so it grabbed that A right there. Now if I was to do this, now that one will print out the outer A function. It'll print out this one. You're reusing a variable name, which you guys will possibly be doing that. If you never reuse variable names, you don't have to worry about this. The other thing is try to avoid using global variables. Anything global should be a constant that should never change in your program. Because what happens is, let's suppose now all of a sudden that function has changed the global variable, and I've got other functions that assume that it does not change, right? Outer A is 50. Oh, what happened here? Oh, no, it didn't. I see, I gotta do this. I think that's how you do it. Yeah. I'll have to check into that. All right. We'll skip that portion. We just did that. Okay. Okay, modules. Things like CSV, sys if you want to get access to your system stuff, information, arguments. There are dozens of them out there. If you're interacting with AD at all, you want to interact with your AD servers, LDAP3 is the module you want to use. If you want to send mails, you manipulate dates and times. If you want to interact with other websites, requests, definitely use that one. Does anybody here do a lot or work with regular expressions? Does anybody know what regexes are? A few. Okay, regexes are magical heaven. They allow you to take little bits and pieces out of large pieces of garbage data, unparsable data. You can pull out the stuff you want. And I'll give you some examples on those. But that's a really good module. Yeah.
Do you know any Python libraries that are good for like character encodings? Like we have students that will do like an emoji, and that's screwed up some of my scripts before.
Oh, yeah.
So what are your thoughts about that?
Yeah, they have character encodings. They have a whole bunch of them out there.
Do you have, is it in the standard library, or do you have any suggestions?
No,
where I should look?
you have to import some of them.
Okay.
Yeah, I know that much.
Cool.
Okay, we've talked a little bit about, I mentioned this, definitely use CSV for humans if you can. Machines like JSON or XML. You can either do input via a prompt, like this, or you can do it on the command line. I prefer the command line because then I don't have to sit there and type stuff in at prompts. Prompts are best used for lower skilled users that you want to give to them. Validate your input as much as possible, and we'll talk about that. If you are writing something that's going to go on a website, or you're writing a script that you're going to give to a lower skilled user, figure at least 20 to 30% of your code will be validating the input. Just assume that. Because if you don't, they're going to run it, and especially if your script maybe plays with your Active Directory or something, you got to be really careful what they stuff into it. You want to make sure it's correct. So file I/O. You never want to read and write to the same file at the same time. Always use two files, one for reading, one for writing, or multiple for reading, multiple for writing. Don't do reading and writing to the same file. It's an error I see a lot of my students make. Python has a thing called a with statement that we'll cover in a little bit. That's a really cool statement in that it automatically closes the file properly when you're done. So I got my program. Let's suppose I'm opening up a whole bunch of files. Each one has a little bit of data on a student. So I've got maybe 50,000 files, right? And I'm opening them up and closing them and opening up and closing them. My operating system has a limit of no more than 1,024 files open at the same time. I have a bug in my program. I don't remember to close files. It crashes all the time. I can't figure out why. If I use a with statement, it will automatically close the files. It protects me from myself. And they've got great modules to do a lot of the reading and writing. Okay, what do we got here? Counts. All right, we're going to wait on that then. Regexes. So these are how you pull data out. So if I have a line from my DHCP server and I want to pick out just a few pieces of data, I use a regex. It looks like a mess. They are a pain to create. Don't bother trying to create them yourselves. Go to the website. If you've never done regexes, I highly encourage you to go to the first website. And let's go pop this up really quick so you guys can see it. This one will take you through, whoops, oh, no, that's not what we want. All the basics of how to do a regular expression. Really worthwhile spending a couple hours going through this if you've never done it. Once you've actually done a few of them, this is the website you go to. Always make sure you pick Python. They have different types of regexes. They're all roughly do the same thing, but they're a little bit different, so make sure you pick Python. Once you pick Python, you put in some of your test data here. So if I come over, that's test data. I'm probably going to have a whole bunch more lines, right? I might have 20 or 30 lines of data in there. Then if I want to pick out everything, here, I'll kind of make that bigger for you guys. Not much bigger. No, we'll try a little bit bigger. Nope. There we go. Dot matches anything, dot star. Okay, I matched the entire line, but I don't want that. I just want the IP and then the MAC address, for example. So I'm going to go all the way up to DHCP, CK, space on, space. You can see it got right to there. That means save everything. From here on out, I'm going to save everything. So now everything in green has been matched in what they call group number 1. Group number 0 is the entire line. Group number 1 is green, but I don't want everything, right? I want to match up to basically space TO. Aha! I've matched my IP address. Then I want to go a little bit farther. Bracket, dot star, bracket, and a space. Not quite. Why is it not working there? \star. There we go. So now I've basically pulled out the two things I care about. This is just godsend. You can basically look at any of your data coming in. You can easily build up a regex that'll perfectly match it, throw that in your program, bingo. You've now pulled out of some big mess of data the exact things that you care about. Right? So regex101.com is just the only way to go for this. Yeah.
What's like the craziest story that you have where you felt like it was a superpower, where somebody asked you to do something and that, I mean, I'm just trying to give a practical example of how powerful this is, because I've used it a lot, but I figure you guys have an awesome story.
I don't know about a story, but I'll give you some examples of how I use it, because I got some code examples later on. I pretty much use it almost exclusively now for everything, even on some of my comparisons. Instead of trying to do a logic comparison, like equals, for example. It's really easy for the thing you're equaling to have a hidden character or some piece of garbage in there. But if you use a regex, you're going to match it exactly, because you can make sure you don't have any of that garbage laying around. All right, that's that one. What's this one here? Okay.
So are you intending to use regex as for data validation then?
For what?
Data validation?
Yes, you definitely use it for data validation. You can. I'll show you some other ways of doing it. Now, this is something that very few people know about Python. It has a built-in debugger. This is probably the most useful part of Python. So you have a program, and it's breaking. Syntactically, it's okay. It runs. It just produces garbage, and you have no clue why. You don't know if it's because you got some bad data coming in. You don't know if it's because you have bad logic. You just know it's not working. This is how you fix it. You get into the debugger. It's built into Python. You just run it. You can then single step through your program. You can list all your line numbers. And what we're going to do is we're going to actually go through a short debugging session. So we don't need that anymore. Page. So I have this thing called hello.py. Yeah, it's a Python program, right? Cool. Let's see what happens when I try to debug that thing. First thing, quit. We'll get out of here. Three. Aha! I have a syntactic problem. It's not working right. And it tells me, uninspected indent. I didn't do that right. So I go back here. Okay, I go down to that line. I'll fix it. Let's go try it again. So what I'm going through is a standard debugging process. My two windows, I'm trying things out, right? Another syntactic problem. Come back down here. Oh yeah, I've got to put a parentheses around those. In Python 2, you don't need parentheses. In Python 3, you do. And if I go down here, oops, I probably need to put parentheses there too, right? And this program is supposed to print out hello world. That's the whole goal of it. Oops, more syntactic problems. At this point, I still don't have valid Python code. The interpreter does not understand what the heck I'm telling it to do. That's right. After every block, I have to have a colon. You also know that everything is color-coded here. That's a string. My keywords are all in gray. My functions are all in blue. So the coding gives you, the color coding will give you some sort of feedback. And Notepad++ will do this. The code editor will. The VI editor will. So that's really useful. Oops. That's not going to work, is it? Ah. So it's trying to treat error as a variable. But I want it to print out the word error. So I need to convert that into a string by putting quotes around it. Okay. It printed out the word error. I'm trying to print out my message. So now I have a logic problem. Syntactically, that's a valid Python program. Doesn't do what I want, but it's valid. So this is the first step. You first get all your syntax stuff fixed. Then you sit there and you come in and you do this. That drops me in the debugger. I can do L and list all my lines. If I hit N, it moves forward one line. And now A is equal to 11. Print A. Okay? If I hit N one more time, it moves forward one line. Oh. L. There we go. And if I print message, I can see the contents of it. So I can single step through my program. Now if I have a big program, you're not going to want to do that. But let's just continue. Any idea why I jumped to the error line? Can anybody see my logic problem in there?
It's less than 10, but it is 11.
That's right. Line 7, I probably should have had a greater than in there. So we'll quit. Go back to the debugger. Now at this point, I know the first two lines seem to be okay, so I don't want to have to sit there and hit N all the time, right? So I'm going to put a breakpoint on line number 7. Oh, okay. Next. And you see the little B there? It says there's a breakpoint there. So if I was hit to continue, it'll run directly to that breakpoint. It won't, I don't have to do anything in between. So let me do that again. Breakpoint line 7. B space 7, sorry. Continue. I didn't have to hit N. So if you have a longer script and you've already got the first part of it working okay, you can put the breakpoint later on. Now let's see. Hi, it's my message. And it's restarted. Let me see. What? Continue. Continue will just run. Oh, continues to my breakpoint. And it printed out the message. The message isn't quite right though. So the last thing I wanted to show you is if I go like this, print MSG, you can actually modify things inside the debugger. So now when I run, it prints it out correct. So when you're playing with trying to figure out what's going wrong in your program, you can actually modify things. You can play with them. It doesn't affect your main code though, so I still have to go back up here and fix this. But of all the programmers I see, or scripters, very few of them know about the debugger or will use it. They put in a lot of print statements, you know, and they print out this, print out this. That is really inefficient. Spend some time to learn how to use the debugger. It will really speed up your work. Yeah. What?
Is there any reason you do single versus double quotes?
No. The Python standard is you use one or the other. You can use single quotes, you can use double quotes. The interpreter treats them exactly the same. I tend to try to use more single quotes, but this is an older program I wrote. Okay, let's see here. Okay, script patterns. So for the rest of this, we're going to kind of go through some patterns. I'll show you this real quick. These are the things that you can take home with you. So picking data from a log file, pulling data out of AD, creating a CSV, looking up MAC addresses, working with a website. Everybody have the problem where somebody's trying to hack into your systems and you wonder where they're coming from, right? You want a little script to do that? We'll have one. Checking user input. All right, so the first one is picking data from a log file. I have a log file. abc-l dhcp.log. It's got 5,000 lines in it. I do about almost 800,000 lines a day in my DHCP logs. Somewhere between 800,000 to 1 million lines a day. So I've just taken a little tiny section. So I'm going to output my results as a CSV because I want to give them to somebody else. I'm using my regular expression parser. I have a main program. And then down here it says if you're running this directly as a file, run the main program. If not, don't do that. So I'm going to look for my scene host. So what I'm trying to do here is I'm trying to find out all of my hosts that have a name starting with C and then a bunch of numbers. In our district, we've got Macintoshes. They come in waves. Like we have the A Macintoshes, the Bs, the Cs, the Ds, the Es, and so on. We had something going on with the Cs, so we wanted to pull out all of those ones and find out where they were in the district. Great. So I can pull this out. I don't want to get duplicates. I just want to find that host once. So first thing I do is I use the with statement to pull out, to create my output file. This little trick here means I will get one line. If I don't do that, you'll get a space between every line in your CSV. So I create a file handle. That basically is how the program uses to sit there and refer to the file on disk. I then attach the CSV writer to it. Add a header line, host and IP. Then I have to read in. So this is really typical. My output file comes first. Then I'll read in my input file. R means read. For every line in that input file, I'm going to get rid of the line characters at the end of it, the line feed characters. Then I'm going to do my regular expression search, and I'm going to pull out the 2 bits of data I want. I don't care about the other things in the DHCP stuff, just the ones that actually acknowledged it. If I find a match, I'm going to pull out the host will be in the group 2 of the match. If I've seen it, I'm going to skip over that. I've already seen that host. I don't need to know about it again. So this is a dictionary. If I haven't seen it, I'm going to add it to my dictionary. So next time I come around, I won't be recording it. I'm going to grab the IP. I'm going to write it out. DHCP.py. And that's what I get. So I've taken this file here, which is garbage. I can't give that to anybody. And I have easily converted it into that file there. So let's try this like this. I'm going to hit continue. It's going to break on line 11. I didn't have to type all of my lines, right? I didn't have to type N a whole bunch of times. Line 11 is right there. There's my thing. Let me see here. Let's go down to line number 18. Let's go break On line 18, sorry. Continue. I broke on line 18. M is equal to none. So now it's just going to skip right back over that and go up there. Continue down to line 18. Print M equal to none. So it's skipping a whole bunch of lines in that file. So let's get past that. So I disabled the breakpoint on line 18, and we're going to create one on line 19. Okay. So m dot print m dot group of 0. That's the whole line that it matched. That's my computer name. That's my IP. And my dictionary is empty. So if I go continue now I have that one line in there. So it will never ever write that host back out to the CSV file because it's already seen it. This is a really common design pattern for parsing logs. I use this all the time, probably once a week, where I got to parse a big log and suck it down to something I want. And just to give you an example here. Oh, let's go rerun that thing. Oh, there we go, quit. So it took 5,000 lines and sucked it down to 50. Right? 50 lines that are now useful data. So pulling data out of AD, let's see if this is going to work. So I'm going to use my LDAP thing. So here's a trick. If I just do an import like CSV, you know down here I have to take the module I imported and then the function inside that module, .writer. I can also say from sys import argv, then I don't have to type sys.argv, I just use argv. Or from LDAP, import these directly. So what I'm doing here, and like from getPass, import getPass. So basically what I'm doing is I'm pulling out, I'm going to grab my AD password. I really didn't want to show it to everybody. So this will enter in a password and we'll hide it as it enters it. I'm going to create a connection to my AD server. I'm going to do a search. And then on what results I get back, I'm going to go ahead and write out a whole bunch of data. And then I'm going to parse those results. And some of them might be empty. So if the account.mail is empty, I'm going to set it to blank. If not, I'm going to set it to the email. Because sometimes when you pull data out of AD, some accounts may not have all their attributes filled in. So you have to put something in there. So I do that for my title, for my location, and then I spit it out. Here's how you connect to AD. This will work with any AD server. I give it a server name. I'm using SSL. You got to use SSL with AD. I have my connection string. That's the account that I'm allowed to connect to AD as. And I give it the password. I'm passing the password in right there. Whoops, I'm using it right there. Then I do a search. That's the OU I'm going to search. I'm going to look for everybody in that OU. I'm going to grab these attributes. With Python, you have to tell it the specific attributes you're going to get. This might be a little bit slow. We're working over the VPNs to my AD server right now. While that one's going, let's go look at this one. This is one you guys might like. So geolocate. So IP Stack is a really cool little program. There's a lot of these services out there these days that allow you to, instead of just typing stuff into their web page, you can call them with a program. So IP Stack is one of them. If you have an IP that's attacking you and you type it into here and you want to figure out where it's located, right? Okay, you can do that on the web form. That's great. You can also do it via a little Python program because they have an API. More and more things have APIs in them. Pretty much that's where the world is going. It's a really good thing to learn. So what I did is I signed up. When you sign up, it's free. You get an API key. You can do the same thing with Google or Azure. So I'm going to take my sysstart. Here I have my sys request is the thing that allows me to talk to the web. JSON, again, remember how I told you web programs like to talk JSON? This talks JSON, so I have to convert that into something that I can understand. So I'm taking my argument, which is going to be if I don't have an argument. So right now I'm saying I have to have an argument. sys.argv of 0 is always the name of the program. sys.argv of 1, 2, 3, 4 are all the arguments to the program. So if I don't have at least 2 of them, it's going to break. Other than that, I'm expecting a IP. Then I'm going to go, that's my URL, the IP, my access key, my output is JSON. I'm going to go execute it, actually call that website. If I get a valid return code, hey, it did something good. I'm then going to convert the JSON mess that I don't understand, but computers do, into something that I can understand. That's a dictionary. And then I'm just going to print it all out. So if we do /geo IP, and I think I had some of these here. Hang on a moment. View notes. How much time do we got? Okay. Now let's do this one first. This is actually kind of fun to play with because you'd be amazed at where things are. That's San Antonio. That's actually the North Shore website. We buy a service and they're hosting it in San Antonio, Texas. The other really cool thing is this actually changes now and then because they actually host it on Amazon and it might move between different Amazon data centers. Right? Or let's try this one. That's NHK Japan. My wife is Japanese. She likes to watch that all the time. So when you go to a foreign country, you often only get the country and stuff, but you also get the longitude and latitude. You can type that into another website. So if you want to have a good homework, take this thing home. When you see something where you don't get the country, I mean, you don't get a city, state, or zip code, grab the longitude and latitude, find a web service that will take longitude and latitude and actually give you the foreign city name. Or map it on Google Maps. You can do that too. It's just another web service that that you'd be using. And one more. Oh, where am I here? There I am. That's the ACPE Northwest.org website, hosted in Bellevue, Nebraska. But this is actually really useful, especially as a command line. Because if you're working hard and all of a sudden something comes up, you need to figure out what that IP is, or what's going on with it. You've got the script, bang, you've got it. You don't have to open up a web page, try to find the geolocate site and stuff like that. And more services are doing this. I probably should have picked a smaller bit. That's really slow. Well, we'll see if it'll finish today. This is one where this would be like a script you might give to somebody to create a CSV of contractor accounts, or something that is not in your automated systems that you got to create accounts for, right? Maybe generic accounts or something. But you don't want them to just fill out the CSV because they might not have the things in the right places. So you write a little script that'll make the CSV for you. And the thing is you want to make sure that they enter the right type of data. So I have in here some prompts. First thing, you can't have an empty first name. Got to have a real, you have to have something in the first name. So I'm going to say, you got to have a first name. You're going to continue to enter something until you give up. You have to have a valid school name. If they enter in something illegal for a school name, I'm going to say try again. So what I do is I have a loop here, while true, until I get a valid school name, until whatever they enter is in this array up here. When it's valid, I break out of my loop. Great, you give me a valid school name. If not, I give you some feedback saying, hey, try again, please. This is a way to validate data. And you can see the breaking from the loop when I'm totally done, right? So if I try that, nope. Nope. It's really picky, right? Okay. Nope, I want to enter somebody else. Really simple program you can give to somebody. If you're on a Mac, there's a tool called Platypus that'll wrap this into a nice little GUI. And people can just click on it and off they go. I'm not sure about Windows. Accounts, DHCP, GeoIP. Oh, the last one is this. Is another thing I tend to use a lot. Let's suppose you need to write out a whole bunch of lines, a big CSV or a bunch of commands. A lot of people will do this with a Excel spreadsheet or something. You're doing like a mail merge type of thing, where they're all the same except for 2 or 3 values in the command. So in this case, I'm creating a whole bunch of ranges for my DHCP server. We're going to redo all the ranges. They're all basically the same except for just a few values in them. I don't want to type this thing out. And I'm not super good with Excel. So Python comes to the rescue. So first I have all my ranges defined. AH has a range of 101, BC has a subnet of 125, so on. These things right there, shift $. That is a line continuation. So this whole thing is really one big line according to Python. I got my header row, right? I put blank values in. Then I'm going to create my row. It's going to be 10 dot whatever my network is, dot this, dot whatever my network is. So I can take that little bit of code now that's kind of bad. Let's do it. And I have turned that into a spreadsheet that you guys can hardly see. There. That now can be imported. The really cool thing about doing it like this is when your boss comes back right after you've made the change and says, oops, we told you something wrong. We really needed it like this. All I have to do is go into my program, change a few things, boom, and I'm done. I don't have to spend an hour doing it all over again, right? Or 2 hours or 10 hours or whatever it took to me to do all this by hand. First, another thing is when I do it by programming, I'm guaranteed everything's correct. If I got one line correct, they're all going to be correct. Because programs don't make typos, where humans do. Well, I'm not sure that one's ever going to come back.
Is that waiting for a password prompt?
Oh, no, I think I already hit the password. It's just, I tested this on our network and I didn't realize how many accounts I'm pulling back. I'm actually pulling back about 4,500 accounts, but it's taken way too long. So we can check something though. We can look at this. No, it hasn't even started writing things out yet.
You could use S.
So let's try this. We'll modify that just a little bit. Let's change the search. I want to search for everybody that starts with Z. Yeah, let's try that. That will shorten down the number of accounts a lot. So that might actually come back. So while we're waiting for that.
It did.
Yeah. Oh, okay. There you go. So I can pull out data. I do this quite a bit. I'll get a thing from, we're using a tool called MailChimp or something. They say, hey, we need to mail to all these people. Great. I have a script. I can pull out whatever bits of person they need, however they want it for MailChimp. And if I keep getting bugged about it, I'm going to write a little front end to it so they can sit there and figure out what they want to do so they don't have to talk to me. Yeah.
Would you use Python to create Active Directory accounts?
Yes.
Yeah.
Yes, you can definitely. We have scripts where we use Python to modify attributes, create accounts, everything else. Yeah. So Python is a glue code. It glues things together. Allows you to modify things. The last thing I wanted to talk about is this concept of modules. So you've seen that I've got this thing, right? And I've got all these functions in here, right? So I've got this function called input no empty. Maybe I want to use that inside another script, right? So I can do this. Python. Oh, actually, let's go through this one. Let's see that the way it was. I'm going to test this. Okay, that ran. I have now imported that accounts file into my shell. So if I was to do something like accounts dot or ABA equals accounts dot, what is that function? Input underscore no EMPTY. So I'm reusing my code. Think about that. So as you sit there and you write a thing and you break it up into nice little functions, you can reuse those functions in your other scripts. If you start doing this a lot, pretty soon you're going to have one file with a whole bunch of functions that you reuse all the time, like that AD search function or that AD connect function. That doesn't change for all your scripts. Why copy it between all your scripts? Put it in a file and then just import it into them. The other advantage of that is when you have to change it, you change it in one spot and all your scripts pick up the change. You don't have to go to every single script and update them, right? So modules are really, really powerful. Okay, we've done that. Just 2 more slides. So getting help, Google it. Look for the Stack Overflow or server fault. Definitely the way to do it. There's a lot of other good places out there, but those are the best ones. Look for a simple solution. If the stuff you're doing and you start realizing this seems to be really complex, you probably didn't find the best solution for you. You can join a meetup, take a class. Python.org has a great community forums. If you want to, you can email me. I teach Python class at the local community college. I don't mind answering questions. I'd like to see people use it. It makes their lives easier.
How long have you been doing that? Teaching up there at the
I've been teaching college classes probably close to 20 years now.
Cool.
At Bellevue, I've been teaching 5 or 6 years.
Cool.
I teach a scripting and automation class, and mostly it's Python. We learn to use Amazon. We learn to use Git for source code control. The kids can't submit homework to me unless they use Git. It's the only way they're allowed to give me homework. Docs.python.org/3 is where all the Python 3 stuff is. They have a really good tutorial up there. Work your way through it. If you're one of these persons like to read a book, there's a couple of books up there that you can use. If you have access to Lynda, there's a couple of good Python tutorials on Lynda if you like to look at videos. But pretty much it's just a matter of spending a little bit of time and playing with it. And it can make your life a lot easier. So, that's all I got. We've got, what, 3 minutes for questions? So any questions about Python or using it in a server environment?
How do you, so you're using you tend to use single quotes for string handling in Python.
Yeah.
How do you escape out a single quote, like
A backslash.
The backslash. Fire.
Yep. Or sometimes you'll switch to double quotes and then you don't have to worry about escaping the single quote, right? Yeah.
Are there some situations where you choose not to use Python as opposed to another scripting language?
The only reason you wouldn't use Python is if there are certain modules in Perl that Python doesn't have. So if you're working with a website or something that says, hey, I've got a SDK for JavaScript or something, or Perl, but not Python, I'm going to probably use the Perl one because it's easier. But right now I'm switching all my Perl stuff to Python because it's easier and it's a lot easier to maintain. And the other thing is, Perl is for people over 40, and all my younger people coming up know Python. And I'm hoping to retire in a couple of years, and they want to be able to maintain this stuff. They're not going to read my Perl code. Forget it. They will read the Python code, though. Any other questions? Appreciate you coming out this early.